Okay guys, welcome to today's video where we're going to take this do-it-yourself gauge pod and actually build it into a circuit board. So we now have circuit boards to build our second version of this board. So this was a similar setup. So if y'all caught the video on this, which there'll be a link somewhere in the description or in a card, this guy is the original version where it's Arduino based. So it's got a AVR chip on here, and then it's pretty simple. It all runs on 5 volts, but I didn't have a good communication protocol on here. It's just kind of like proof of concepting to myself that I could make something like this. So this is the second iteration of it, where we used a STM32 instead of an Arduino. We used CAN bus, so that way we had a communication protocol, and then we used a DRV 8833 instead of this ST chip, because this chip's like $5 a piece for them, and it's really inefficient. Also, there's just this H bridge is just not a very efficient H bridge, while these DVR 8833s are a whole lot cheaper, closer to $1 a piece, and way more efficient because they're MOSFET based, while the other one's transistor based. So yeah, just a couple little differences there. I got an idiot light, and then it's got RGB lighting on there, so that way it can match your computer. But no, jokes aside, it is just so that way in we don't have to change the LEDs for different applications pretty much. And just over CAN bus, you just tell it what color you want the LEDs to light up, and they light up that color. So yeah, very, very, this is supposed to be as universal and robust as we can get. Now, this is still not the final one, but this is the final size of one of them. So I'm going to do two different sizes. This one, which is going to be the 3 3/4 inch gauge pod, and then also do the smaller 2.5, I believe is the size of it. The reason why I did this before the 2.5 is because the 2.5 I'm gonna have to sandwich 2 circuit boards to fit everything, while this one I was able to do is a single board. So that's why we're here. This video today is sponsored by NextPCB. They provided me with the PCBs to do this video. So let's get into the sponsorship portion of this video, and then we'll continue on with the build. All right, so today's sponsor is NextPCB. They've sponsored us previously on the channel. NextPCB has some, first, before you even need to start ordering your PCBs and everything, they have NextDFM, which is a free software provided to them for it after you've designed your PCB. So you took all the time, designed everything in KiCad, you've exported everything, you got your Gerber files, and now you're like, okay, let me send them to the manufacturer. Well, first run them through NextDFM. You use NextDFM to make sure that you are fitting all of the manufacturing criteria, because not all of your software does that for you. It doesn't let you know ahead of the time. KiCad is not the best in the world at doing your, checking for design errors for the manufacturer side. You put something too close to a drill hole, so it's out of spec for the manufacturer. So NextDFM helps you catch those kind of issues and prevents it. So it's really great software that's free. And the other great thing is you get an estimate of what your cost is going to be from NextPCB in that software. So that software definitely is very useful software. Even if you're not going to order with them, I highly recommend the software. It's just hands down really helps you get everything, and it's pre-programmed in with NextPCB's design spec, so you don't have to set any of the settings. It's just good to go, preset. While if you're trying to do the same thing in KiCad, you have to change some settings. But yeah, they have trial PCB orders for absolutely free for the new members, and you get free shipping if you have a PCB assembled on site, where they do on-site assembly. So definitely very reasonable costs here, especially a free trial order where all that you're paying is shipping. 2-layer PCBs, where it's not your trial order where you've been ordering from before, are still very affordable. 4-layer PCBs, $12. That's just unheard of. Manufacturers here in the United States, you're looking at $33 for a single PCB that's 2-layered. You know, like you're not even going to get a 4-layer for that. So yeah, these NextPCB, absolutely, they haven't met. You know, they haven't let me down at all on a single order. I've been using them for a while now. They're my go-to source for circuit boards. I mean, yes, they sponsor the channel, but I've been using them for circuit boards from before. Before we get started on this build, let's go over some little nuances of the design that we are not going to get into. We'll just go over what's going to be changed on the next iteration of it. So first, this one. It was hard to tell how close I was, but yeah, this is a little too close to the edge for my comfort. I'd like to move it to about there. So that'll be a change you see in the next design of this. I believe I'll probably move the LEDs in a little bit closer towards the stepper motor also. So just move these in just a hair so that way they shine up to it. Again, just something that's hard to tell from the design. I'll probably remove these the silk screen that says the screw hole size. It's kind of silly. I don't know why I put that there. I'm gonna label the test points. I need, I just put test point 1, 2, 3. I should have just labeled them. It'd be more useful that way. Also going to put a star or asterisk here just to mark the pin 1 location of the microcontroller. Other than that, I'm pretty happy with the way this design came out. I think everything is definitely going to work out good. I may look into flipping this. I may look into moving this capacitor over to this side of the board. We'll see how tall the stepper motor is in comparison to that. That might be a possibility to move that. So also we're going to remove this crystal, and oh my god, I was absolutely insane thinking I might be able to hand solder on those capacitors there. I don't actually need this crystal. It has a internal crystal for doing real-time clock stuff, and I'm not using any of the real-time clock features at the moment. I left it because I wasn't sure if maybe I was going to need it with doing some RTOS kind of stuff in the future, but I decided I'm not even going to worry about it. This crystal can just completely go. Main thing that pushed me to that decision to just eliminate the crystal is I designed around this particular one that I was very happy with the specs on. I was very happy with the price on it. And now with the chip shortage, it's not going to be available again until September. And then once that shipment has made, they don't know when they'll have them again after that. So the factory is not accepting orders on this particular on any of these components from them in the future. So I don't know. I just have no idea what the state or status is of that component. So I didn't need it, so let's just eliminate it. We'll take that out, and then we no longer need the load capacitors for that. So we're not going to install these in this build, and we won't be seeing them in the future. We do still need this crystal installed, then all the capacitors and supporting stuff there. Maybe in the future I might change from the MCP 2551 to one of the Texas Instruments, the ones that run at 3.3 volts. The Texas Instrument ones cost more, but they're also, their life cycle's longer. So they're like, not like these are gonna wear out, but like the manufacturing life cycle. So these are actually not recommended for new design status. I didn't realize that when I started this build. So yeah, some future changes, but this is definitely a good first design. Another thing, just for this build, we're gonna have to pull the LEDs off of some little chips because I thought I ordered them, but I didn't. So, but I do have some. So yeah, these ones they come soldered on some chips. I have these on hand. I thought I had ordered some more, but I guess I didn't. So yeah, I don't have the individual LEDs. I think what it was I realized that they were super expensive here in the United States, but really cheap from China. And I meant to make an order with a particular vendor in China, and I just didn't. So yeah, we'll be salvaging these guys off of those circuit boards. Yeah, and then we're not actually using a TVA, a TLV 74033 PDDVR. We're not using that one because chip shortage. They're not available, and they won't be available for a little while. But there is a pin for pin replacement for it from Texas Instruments that is it's a little higher accuracy one, so it costs more. So we're using that one even though it costs more. So it's just short-term use. Definitely once the other one becomes available, we will use this original chip. But yeah, there was a pin for pin replacement of it from Texas Instruments. So we are using that one. It costs 3 times as much for this one, which 3 times as much is like 10 cents more. It's not significantly expensive. It was just one of those. I would have liked to have gotten the cheap one, but we'll use the expensive one in this build. So let's enough talking about it. Let's start building it. You're just gonna be watching a time lapse of me putting this together. Is really how this video is gonna go. It's just more of a time lapse, pretty quick. Throw everything on there and see if it works. All right, so first let's salvage these LEDs that we're gonna need off of these other boards. Again, because it's just my fault for not ordering them. Okay, so that's all there was to salvaging those. Now let's actually get started assembling this PCB here. So there's a couple of components we won't be putting on here. As I kind of mentioned before, we won't be putting the crystal, its load capacitor on there, and we won't be putting the connector on right now because I just don't, I have the connectors, but I don't have the other end of it. So I can't connect to the connector with it on there. So we'll just leave the connector off for now. That'll come back on a future date. And also C14 and C13 won't be going on there just because I made a mistake and forgot to order them. It will operate without those, but they are a important component for the CAN transceiver. So I do eventually need to get that. So that way that just helps with the signal integrity there. So yep, we'll just get that stuff out. Kind of a waste here. These boards, they all have a resistor and a capacitor on there that's going to waste there since I had to salvage them off. The original data sheet for these recommended a capacitor on the power line on it, but then they dropped that recommendation, basically going, it's not necessary. You just need a bulk capacitor, which is the point of this guy here, is to do the bulk capacitance, not just for the LEDs, but for the rest of the board too. So it is actually over the spec needed for the LEDs. But yeah, definitely we got a bulk capacitor on there, and we got the LEDs. So yeah, those will be the components that won't be on here. But yeah, let's get this thing put together. Everything else will be going on there. Might have to change this LED out too on the final product because it's probably not big enough. But yeah, let's get in this. We're gonna go in the kind of normal order you'd want to go into of smallest footprint to biggest, and smallest physical height to tallest physical height. So the last two items to go on will be this capacitor and this stepper motor. Those will be the last two. The first stuff's really going to be all these resistors and capacitors. Some of it, like the voltage regulator, might go on before I get the capacitors over here, just if I grab that bag before. Just depends on what order I grab the bags in, but pretty much any of these chips like this, they're not going to go on until at least their capacitors around it are on, if that makes sense. It's just, it helps with the assembly process when you're assembling a PCB to do it that way. Same with like, this guy won't go on until all of the rest of these are on. And the reason for that is so that way that this is not in the way of trying to solder this other stuff down, if that makes sense to you. So yeah, let's just get started on this. Oh, and I'll have this sheet of paper here by the side. This is the BOM from the from KiCad. I just cut out some of the other layers. There's a bunch of tables to it. I just cut it down to the 3 that I need, which is the designator, the quantity, and the part number. So yep, we'll start putting it together. All right, so it's the next day, and I actually got a package in the mail and put it on there and forgot to record putting it on. But yeah, I got the connectors now, so I got the connector soldered on there, and now we just need to solder to these test points here, so that way we can hook up our in-circuit programmer and program this. I'll probably eventually make a jig for programming these if I sell enough of them. But right now, just gonna do it this way. So just put a couple of these wires on there so that I can program it. We only need 3 wires to program it. It's clock, data, and ground. So that's what we got there. All right, so test point 1 is data. Which one's test point 1? The first one. All right, so data. All right, test point 2 is clock, correct? Yep, test point 2 is clock. All right, well, let's put ground is in between the two. So we'll put ground in first, and then we'll put clock in. All right, then clock. All right, yep. And this is just a ST link that I'm using to program it because it's ST chip. All right, so then I just need to put my connector on here so that way I can power it up. All right, and we have a twisted pair for our CAN lines, and then just red for 5 volts in, and black for ground. So that's the whole setup here. Now let me get this going on the computer so that way we can program it. Okay, so I did this all in Arduino IDE just to quickly get a prototype going, but I do plan on rewriting all of this in Embed. I know Embed's, again, another one that's mostly for prototyping, but I want to try and see if I can use some of the RTOS features and stuff before I step into something a little bit deeper. All right, so now we just need to program it. So upload. This does take a little while to do. All right, so it is working on it. And what we're doing here is we're actually using the ST link instead of a COM port. So to do that, all right, so it says it's running successfully. Yep, and it is pulling current, so it is running. So yeah, let me just explain this real quick though. So what's going on here is we are using the STM32F1 series, a blue pill. We are, so for optimization, I'm going with smallest, and then the upload method, I'm using STM32 Cube Programmer SWD is how I'm uploading it. So that's how that was done, to set it to use this instead of trying to program it over the serial port. So so now we're done in Arduino IDE. We have it all programmed. We definitely have something going on here because the stepper motor did not move. So let's get into that and diagnose why we don't have stepper motor movement. So first we're going to hook up to CAN and just check and see what works, what doesn't work, and diagnose this. Okay, so this might look like a strange setup here. This is a different project I've been working on. I'm actually working on doing GM LAN on here, but I converted the project over to do just the high-speed CAN for now, just that way I can work on this project. I did this a couple of weeks ago. I didn't record any of doing that portion of it. When I do the GM LAN stuff, I will do a video on this project, but for now it's just kind of on the back burner. But all we have going on here is we have a CAN transceiver, and this guy talking CAN, and we have a little menu to go through here. And then you just got CAN high and low to that board, and then our ground and power coming from our bench power supply. So let's go ahead and turn this thing on, because again, like I said, we know we have something going on, we just don't know what's wrong with it yet. So let's first just see if it's receiving CAN messages. So let's start with the sweep gauge, because it's the stepper motor that we know is not working right now. So let's try that one. Hopefully we'll see the error light come on. So there we go. The error light did come on, so it's receiving the CAN bus messages and telling it to sweep the gauge, but it's not doing it. Let's see. Let's come to the lights. All right, all our lights are working also. So yeah, we know CAN bus works. We got lights working, air lights working. So the only thing that's not working is the stepper motor. So we're either going to have a bad connection from the stepper motor to the stepper driver, something wired wrong with the stepper driver, or something wrong with stepper driver to the microcontroller. So let's pull up the data sheet for this, because I'm very confident in my wiring from the stepper motor to the stepper driver, so I'm not really worried about checking that. But yeah, we'll pull up that data sheet and see what we see. Let's first take a look at the schematic from the breakout board that I used to see what we see from that. So this is that schematic. It had reverse polarity protection up here, so that's kind of some of the stuff we can ignore what's going on there. But basically what I followed was our B outs and A outs going to the motor. So yeah, pin 5, pin 3, pin 2, and pin 16 all go to the motor, and then our sleep pin goes to the microcontroller, and then our BN B2, AN 1 and 2 all go to the stepper controller, and then we just have this same setup going on here with the 10 nanofarad capacitor in between them and the 2.2 UF capacitor going to ground. And that's pretty much exactly how I wired it up in the schematic. Let's take a look at the data sheet now. And I think this might be our problem, because I know I left these to no stuff. I did no stuff there because for some reason I didn't notice this right here where the resistors are, you know, they're no stuff, no part there. So I assumed nothing was going on there. But then, you know, there's a jump here that goes to ground. I just, for some reason, didn't notice that. So I think that's our problem. So let's take a look at the data sheet and see what we need to do with the B sense and A sense is what those are. So it's BISEN, and so let's see, what do we get with those? Here's the sense. So connect to current sensing resistor for bridge A, or ground if current control is not needed. So I'm pretty confident that's what our problem is that I didn't tie those to ground because I'm not using current sensing. I didn't put a current sense resistor, and yeah, I didn't put it to ground. So I think it is going into an error state because it's probably assuming that it's got an overcurrent issue. So let's try tying those to ground and see what happens, which I have a second one of these boards that I've already done that to. So let's test that one and see if that fixes it. So I did it with just a little bit of bodge wire on here. So we're gonna plug that in and see if that works. So let's unplug this one. All right, and we'll plug this one in. There we go. Got that lined up. Let's turn on the power. All right, so we now have a working stepper motor. We can go ahead and do a test sweep with it and verify. Yep, so everything is working. So all we forgot to do is tie those to ground. So I'll get under the microscope and try to do some bodge wires on the other one, just that way you can see how to fix that error. So yeah, very, very easy issue to fix. Definitely, I just forgot to tie the ground sensing to ground. But I mean, not the ground sensing, the current sensing to ground. Definitely my fault. Not the manufacturer of the PCB's fault. That is completely my fault in the design. So yeah, easy repair, very easy modification to do to the schematic of it. So that way I don't run into this problem in the future ones. But yeah, it was just a simple mistake I made. So yeah, let's go ahead and switch over to the other camera, get the microscope going, and see if we can fix one of these. All right, so now we've added our two new little bodge wires here that pull the current sensing portion down to ground. So that way it's no longer thinking it's in an overcurrent position. So let's go ahead and power this up. And if the stepper motor zeros, we know everything's working. All right, so yes, everything's working. We know everything's working because the stepper driver chip does not actually zero it on its own. It's getting communication from the microcontroller to move it, and we know that the microcontroller is getting communication to the CAN bus. So everything's verified. This is completely working now. So we have a fully working gauge pod here. So this is really it for the video today, but in the next video on this series, I will be 3D printing a housing for this to turn this into a full-on gauge pod. I don't know if I'll show the whole process of doing it or if I'm just going to 3D print it, put it together, and do a short video for YouTube Shorts. So we'll see what happens there. You can let me know down in the comments if you're interested in seeing a video on getting Infusion 360 and designing the actual housing for this. Or if that's just not something that's really interesting to you guys, then I can just do that on my own and then just show it in a YouTube short of putting this thing together. All right, guys, I hope you guys enjoyed doing this build with me, making this gauge pod. I'm definitely going to do some revision work to it. I don't know how much of the post-revision work will be kept open source on this project. I do have some interest in actually selling this design to somebody. So, you know, hopefully that works out and I can make a little bit of money to reinvest into the channel. I mean, that's really what it would go into, is just making more projects and stuff. But yeah, I'm really excited about the possibility to kind of partner this project into somebody else's product that they're selling. And so I'm going to talk to them and see how much of it they'll let me keep kind of open source, because really, like, who's going to steal this and produce it in mass scale? So I really wouldn't be worried about that. I do need to rewrite all of the firmware for it for doing that, for actually turning into a product, because I'm not 100% sure on the licensing of a couple of the libraries I used in Arduino. Plus, I don't trust the stability of the Arduino code. I would much rather do it in another setting. So we'll see there on where it goes. And by the way, don't think that Arduino code can't be in like final products and stuff. Take you know, there's a lot of products out there that are going to have Arduinos. There's a ton of products out there that have like you have a Raspberry Pi inside there. So yeah, don't think that your hobby tools can't make a product. Just make sure your hobby tools that you're using to make your product with are stable. I just don't trust the stability of the particular. It's not the Arduino code itself. It is the CAN API that, well, not API, but library that I used, that I got somewhere else. I don't completely trust that to be in a product. And I don't feel like rewriting the library for it in Arduino. So I just move over to Embed and use the Embed platform to do it, because it already has an API for CAN bus. And so I don't have to worry about that. I understand that Embed does not have any warranty to the APIs that they provide, and that it'd still be my responsibility to make sure it works properly to go into a product. But yeah, the Arduino platform, I just don't think is the best for this project. But there are plenty of projects that you could take to market as a product that you wrote in the Arduino API, or I mean the Arduino IDE, and it would be perfectly fine. So don't take the fact that I'm stepping out of the Arduino world to make this, to turn this into a product, to say that Arduinos cannot be products, because there are plenty of products out there that have Arduino code in there and you would never know until you knew. But here's an example of one. These are running a Arduino, this has Arduino code on it to make it work. It is an AVR chip, but not only is it an AVR chip, but it's still running Arduino code to work. So yeah, there are plenty of projects out there in the real world that have Arduino code on it. So like I said, don't let the fact that I'm stepping away from that deter you from making your product in that area. Of course, any embedded engineer would be like, oh, you can't do this, you have to do it in, you know, whatever IDE they use, because, you know, they know how. And if you know how, you should. But, you know, I'm a hobbyist. I can't, I'm not an engineer. So, yeah, I'm not going to do that. But that's enough of me justifying it. Again, thank you to our sponsor, NextPCB, for providing the PCBs for this project, because without them providing me PCBs for this stuff, I really wouldn't be doing nearly as many projects, because costs add up really fast. That really helps bring down the cost of doing these projects. Even if these PCBs only cost $2 to get made, to make them yourself, you know, it really helps bring down that cost and let me, you know, be creative with it. So thank you to them for providing the PCBs, and I really hope you guys enjoyed this video. It actually took quite a while to make this. A lot more editing went into this video than my average video. So thank you for watching, and I'll see you guys in the next one.